Okay, yes, please. Can you tell me about yourself?
Yeah, hi. So the project currently we are working on is the project from Google. So I'm working on it from approximately past 2 years. So this project is basically similar to how we have Naukri.com or Sign.com. So we have lots of users and we have various customers and we have students as well, and we provide the login and logout portal, and there are lots of jobs listed over there. So there are various modules. It has like data module, user module, listing module, etc. So basically, I'm working as a full stack developer from past 2 years with this Google project. So basically, we are using Servlet JSP and Angular JS. So these technologies we are using, and we are also using JavaScript, HTML, and in some of the modules, we are also using Spring Framework, and database side, we are using MySQL. And this is all about myself and my past experience.
Okay, can you tell me what process you follow and how do you do the testing of your application?
Yeah, so in our application, we follow a structure and kind of a layered approach for testing the code. And basically, for that, we have a separate folder or package, we can say, in SRC test Java. And the way we have the controller, similarly, we have a separate folder for this. And then we write unit test for individual components like controller, service, or repositories. So these tests are written in an isolated manner to ensure that we are only testing the logic and the specific component without involving the actual dependencies. And then we use JUnit as a primary testing framework and for mocking dependencies and isolating units. So we use Mockito for that, and we also use Spring Boot test annotations like uh, at the rate of web MVC test, at the rate of data JPA test and all, and at the rate of Spring Boot test. And we have and instead of interacting with the actual service or repository classes, we use Mockito to create the dummy or mock object. So suppose any service is there which is, or any third party API calls we are doing, so instead of actually making the calls there, we just mock it, and we can use Mockito for that. So we inject the these kind of mocks using at the rate of mock, or as a inject mock, we can use that. So basically, we write the test cases to verify the functionality and logics are working as expected or not, and there should not be any kind of exception or bugs should be there. And then once that is done, then we go for the coverage of the code. So we use the Jacoco to for the code coverage. So basically, this helps us to ensure that our tests are completely covered, and the important parts of the code base has been covered. And then the tests are integrated into our CI/CD pipeline basically after that, so that they run automatically on each build or pull request. So there we can see if any kind of error is there, any issue is there, so that again we can go and fix it. And again, as soon as we build it, it again the CI/CD pipeline Jenkins, it runs automatically. So yeah, so these are the things, processes we follow while the testing of the application.
Okay, okay, good. So Sonar Cube also you have used?
Yeah, we integrate SonarQube for the code analysis and code quality checks. So basically, SonarQube helps us to detect if any kind of bugs or any security vulnerabilities are there, or any test coverage metrics, or any issue is there. So those things can be checked in SonarQube. So basically, it's part of our CI/CD pipeline. So each code commit or pull request triggers the SonarQube scan as well. Okay, so the SonarQube dashboard, we can see the clear overview of the code quality matrix, and there we can see coverage or any kind of duplication is there or complexity is there. So those things we can see using Sonar Cube.
Okay. 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 So in testing, what are the different levels of testing usually we see in the application?
Yeah, we have initially we have unit testing. So like each individual component we test as a part of unit testing. So each methods, functions, or it can be classes. So those things we test as a component. And then we have integration testing. So we integrate between various units or modules, and then combinedly we test it. So uh, it, so basically it checks if components like service repository or external APIs are working together correctly. So that is what is integration testing. Then we will have component testing. Okay, so to test a specific part of application in a somewhat isolated but broader scope than the unit testing. Okay, so testing, uh, so for example, testing only the controller layer using the at date of web MVC test in Spring Boot. So that will come under component testing. Okay, and then we have system testing. So basically, testers do that using the Selenium and all. And then we have end-to-end testing as well. So like the whole real user behavior. So it involves the all the interactions happening from the UI till the database. So combinedly how it is working. So that we say like end-to-end testing. So yeah, so these are the various types of testing I'm aware of.
Okay. 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 So do you know TDD, test driven development?
Test-driven development, yeah, I have used that.
Okay. Can you explain in very brief?
Yeah, so basically, test-driven development is a way of software development in which, like, we initially just write we start from writing the test case first, and then we do the development. And so basically, it starts from the red, and then it goes to the green. So, like we write a test for a new feature or a function, so it will fail initially because the functionality does not exist yet, so it will be red, and we try to make that to green, so we write the minimum amount of code required to make the test case pass. So when it is green, then we say that okay, this is the code we need, and then further we refactor it as well. So we clean up the code and we improve the structure or readability, and we ensure that all test cases are passing properly. So so this is what is the TDD.
Okay. So you know API gateway, right?
Yeah, I know that. So we have used Spring API Gateway.
Okay. So suppose you have hundreds of APIs, right, in your project. So how they communicate with each other using API gateway?
Yeah, so basically, API gateway, we can say it as a single entry point for all the external or sometimes the internal calls. Okay, so whatever call or whatever the client call is being made, so that is supposed to come through the API gateway, and API gateway is the one which decides that it has to go to which URL or which microservice it has to hit. So basically, this API gateway is a server that acts as a intermediate between the client and the backend services. So here, apart from routing the request, it also responsible for the security and rate limiting, logging. So all these things are done in API gateway. So internally, so once any client call happens to the API gateway, and after that internally services may still communicate with each other directly or via service discovery. So I have used Eureka for that, and basically it depends on the architecture. So basically all these APIs, 100 plus APIs, whatever we have, that does not need to be directly exposed to client, and the gateway is the one which handles the routing. So this API gateway basically we can configure using the appropriate libraries and dependencies. And we are also going to do the configurations to route the request to an appropriate service inside the configuration application.properties or YAML file, which contains the paths and predicates. So we can route the request to an appropriate service, and as part of this API gateway, we can write the filter logic also, and using that we can perform authentication and authorization also. Or if you want to run or request uh, any main logic before the
Mhm.
main logic.
Okay. Okay, what is service registry?
Yeah, so service registry is basically like a kind of we can say directory where all the microservices register themselves and discover other services. So here we can see the name, URL, and each service is running, and how many instances are running of each service. So for that we are going to use a Eureka server mostly. So basically whenever a service starts, so it registers itself with the service registry. So in service discovery, so other service query the registry to get the current location of the service they want to call. So it can be client side, and or it can be server side as well. Yeah, so yeah.
Okay, so for handling the centralized logging in microservices, so how do you do that?
Yeah, so for that we use ELK stack. It sends the logs from each microservice to the central system for monitoring and analysis.
So for visualization of this log, do you use any tool or anything?
Yeah, we use Kibana for that.
Okay, okay. Okay, so what are the Spring Boot starters?
Yeah, Spring Boot starters are like we can say predefined and ready to use sets of dependencies. So which we can use while configuring the project. Like if it is Maven, then in pom.xml we can configure that. And so we have basically, for example, Spring Boot starter web is there, so that we can add in the dependency. So this starter includes everything we need to build a web application, including like MVC, Jackson jars, and embedded Tomcat server. So all that comes under this. And then we have Spring Boot starter data JPA. So all JPA related and Hibernate related jars will be downloaded using this one. And again, for example, let's say we have a Spring Boot starter test. So in that case it downloads the all the dependencies of JUnit Mockito and a Spring test. So all that related jars will be automatically downloaded, so we don't have to manually go and see the versions and compatibility. So yeah, we don't have to check that, and it will do the job. Yeah.
Okay, okay. And what is Spring Boot auto configuration?
Yeah, auto configuration in a Spring Boot is like it configures the Spring beans based on the project's class path and the properties set in application.properties or YAML file. So it basically removes the need for us to write explicit configuration code. So all the boilerplate codes are removed because of this for the configuration level. So it enables through at the rate of enable auto configuration. So it automatically included when we use Spring Boot application basically. So yeah, so this is the part of at the rate of Spring Boot application. So yeah.
Okay, so what are the other components which are the part of at the rate of Spring Boot application?
Yeah, other components are like at the rate of configuration, at the rate of enable auto configuration, and at the rate of component scan. So yeah, so these are the three which comes under this. So add configuration, basically that marks the class as configuration class, so allowing it to define beans. And at enable auto configuration already we discussed, like it tells the Spring Boot to automatically configure the application based on the class path and other factors. And add component scan allows Spring to scan the current package and its related sub packages for the beans if anywhere it is there. So it will automatically register those components to the as a bean. Yeah.
Okay, so for exception handling, what steps you follow? It is Spring Boot.
Yeah, in Spring Boot, we do the global exception handling normally, and we can use add controller advice for this to handle the exceptions across all the controllers. And add exception handler method within the add controller advice can catch a specific exception and return custom responses. So on top of the class level, we can just say add controller advice, and inside the method, whatever we are writing, so there we can write add item exception handler, and yeah, and we can write whatever the method we want, what the response we want to return as part of that error, so that we can mention in that method. So that custom error response we can return. Yeah.
Okay, okay. Okay, have you used Spring Boot dev tools?
Uh, Dev tools, yes, I have used, but while production builds, we should exclude it. Basically, we can use this Spring Boot dev tool as part of dependency. Okay, and that we can use for like various debugging purposes, we can say. So the various features it enables usually, so like it automatically restarts our application when the changes are made to the any code base, so it will automatically restart, and it will refresh the browser when static files are modified. So for front-end development it is very much useful basically. And for debugging also, it provides like better debugging support and automatic resources loading, so that can be done. But while giving the final build, we should usually remove this. Yeah.
Okay, so what is the Java and Spring Boot version currently you are using?
Yeah, currently we are using Java 17, we have upgraded recently. And then in Spring Boot we are using 2.7.
Okay, so any further plans to upgrade Spring Boot from 2.7 to any other version?
Yeah, so actually we are planning to move Spring Boot to higher version like 3.x version.
Okay, and have you done your analysis that what the challenges you might face while upgrading the Spring Boot to 3.x version?
Yeah, some analysis I have done. So, for example, the all Java X packages now they are Jakarta. So, for example, whenever wherever we had Java X.servlet, so that is now Jakarta.servlet. So that all has to be changed to Jakarta. And any third party libraries which are using Java X dot star, and that must be updated to the version compatible with the Jakarta. And some dependencies might not be compatible with the Spring Boot 3, so we may need to update or replace that corresponding libraries. and Spring security level also changes we have. So like so security filter chain will replace the web security configure adapter. And also I'm aware about the some changes regarding the Spring Boot starter validation. So I just know that some changes has been done with respect to that, but exactly I'm not aware. But yeah, and then with respect to testing, also some changes has been done. So yeah, so these are the changes I think we have to take care of.
Okay, okay. Okay, can you tell me when we should use array list, linked list, and hash set?
Yeah, array list is basically is the part of java.util package, and basically we use that whenever we have to maintain the insertion order, and it allows the duplicates. And coming to linked list, so linked list is a um, like doubly linked list. So it is implementation of the list and DQ interfaces. So linked list basically maintains the insertion order, and this also allows the duplicates. And then coming to hash set, so this is basically the part of the set interface. So uh, uh, so internally it uses hash map to store the elements. So it basically stores the things into the form of uh, objects. Like suppose we can declare the set and set dot add we can do, and we can add the data whatever we want. It can be string, object, or anything. And then we can use it whenever we need to ensure uniqueness of the element, and we want like quicker insert, delete, or lookup things. So at that point of time we can use this hash set.
Okay, so can you be a little bit more specific, like when we can use them?
Yeah, so array list we can use whenever we need fast access by index. So suppose any list is there and we want to say get list dot get of whatever 1 2 3 or whatever index we want. So at that point of time we use this array list, and we don't do lots of insertion or removals from the middle or start in case of array list. And coming to linked list, so since this is uh, like the underlying structure is doubly linked list, right? So whenever the frequently insertion or removal of elements is the requirement at the start or middle of the list, so at that point of time we can use the linked list. Okay, so that is the scenario for the linked list. And then coming to hash set, so whenever we have the collection of uh, unique elements as a requirement, so at that point of time we can go for the hash set. So in this case we can do the fast lookups, insertion, and deletions. So basically it does not support duplicates. So yeah, so these are the scenarios when we can use them.
Okay, okay. Okay, can you tell me the difference between JDK, JRE, and JVM?
Yeah, JDK is basically the Java Development Kit, that is the full form, and this is the tool to develop and run the Java programs. So JDK basically includes JRE. So JVM is like a Java virtual machine. So it's part of JRE that executes the Java bytecode, and JRE is a Java runtime environment. Okay, so this is an environment to run the Java programs. So this JRE includes like JVM and other supporting libraries.
Okay. Okay, so do you know what is RT.jar?
RT.jar.
Yes.
Yeah, so this is basically the jar, which is I think this is the part of JRE library. Okay, so all the Java libraries like java.lang, java.util and all. That is the part of this rt.jar. So the purpose of this is to provide the Java standard library for the JVM at runtime. So this is loaded at the runtime. Okay. So yeah, so this is kind of the like out of the box library which comes for the Java.
Okay, so do you know any changes has been made after the higher version of the Java with respect to this rt.jar?
Uh, yeah, I had heard that like this has been removed in the higher version of Java. I think 9 perhaps. So because of the introduction of Java platform module system, so this was removed actually. So there are some other modules has been introduced later on. So that is why this jar was removed.
Okay, can you explain me the internal working of Hasset?
Yeah, so the hash set uh, in Java is a part of Java collection framework, and it is used to store a collection of unique elements. So internally it uses hash map, and it relies on the properties of the map to maintain uniqueness and manage the storage. So when hasset is created, it initializes an internal instance of the hash map. So every element added to the hasset is actually the stored as a key in the hash map. So with a uh, constant dummy objects like kind of its value. Okay, so this dummy object is a static final field. So uh, it is defined inside the asset class basically. So when an element is added to the asset, the element's hash code method is called to determine its hash code. Okay, and this hash code is then processed using the hash function to find the appropriate bucket location within the internal array that is maintained by the hash map. Okay, so so each bucket is like has an index in the array, so which might be empty, or it may contain like some entries previously which we have added. Okay, so if the calculate block is empty, the new entry is placed there. However, if there is are already elements present in the bucket, so in that case collision happens. Okay, so Java basically checks each element in the bucket using the equals method to determine if the new element is already present. Okay, so if equals method returns true for the existing element in the bucket, then the new element we can say as a duplicate, and the whole of these elements are added at chain of like kind of tree structure with that bucket. So in Java 8 or later versions, the um, whenever the size of this the nodes at the same bucket has increased to uh, some certain threshold, so in that case it converts itself to the balanced tree. So that is called a red black tree. So that basically improves the performance during the lookup operation. Okay. Now, some similarly, whenever we do the lookup, so more or less same processes happen, and the lookup is done. And if the item is found at the bucket, so in that case, that address of the bucket is returned. So yeah, so that's the internal working of Hasset.
Okay, okay. Okay, so can you please share your screen and write one a small code snippet?
Yeah, sure.
Okay, so can you please write the code to print the numbers in both ascending and descending order? Both.
Okay, so basically, I have to I have to take an array list and array list of numbers, and I have to uh, write the code to print that in ascending and descending order, right?
Yes.
Okay, so let me do it. So let me take arrays dot as list. So let's say we have 8, 3, 2, 9, 5. So let's say these are the numbers we have, and we will gather it to as list, and after this, on top of this list, we will apply stream, and then we can just say sorted, and then we can simply collect it. Okay, and then we can say here collectors dot, I think, to list. Yeah, so it will let me again hold all this value. So this will basically sort in default natural order, like in ascending order. So now we can print this. So let me sys out this one. So if I print this, then yeah, so we can see the ascending order here.
Okay. How about descending order?
Yeah, for descending order, what we can do is inside this sorted, we can just pass reverse order, comparator dot reverse order we can pass here. So it will reverse the natural sorting order.
Okay. Can you write that as well?
Yeah, so let me copy this again and keep it here. Uh, Let me say this is will be descending order. So uh, inside this sorted, we can say comparator dot reverse. Yeah, so this is the one, and now let me again print it. So yeah, so we can see this is in the reverse order.
Okay. 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 So apart from this, do you know any other way using Java 8?
Any other way to for the sorting?
Yes.
uh,
Can we do it using Lambda?
Using lambda, yeah, we can do that. So in that case also, we can whatever we have in sorted, right? So we can give like we can take as a parameter. So and like a and b we can pass, and then we can say a compared to b, right? And then we can do it. But in case of sorted, there is no need to do that. But in case of sorry, in case of ascending order, there is no need to do that. But in case of descending order, instead of this, we can use that one. So for example, let me uh, write it. So let me say descending one for this, and let me remove this one. And instead of this, if we say a comma b, okay, and then lambda operator, then uh, b compared to a, okay. So if it was a compared to b, then again it was the ascending order, but this way I think it will be doing the descending order job. So let me run it. Yes, so yeah, so this is the way so this is the way we can do it. Yes.
Okay, okay, fine.